reduction of PQ happen. Reduction of who's happen? PQ happen. Understood or not?
Yes, sir.
PQ will donate the electron to cytochrome complex. So now PQ will oxidize. And who will reduce? Cytochrome complex. And now electron will be donated to PC. PC full form is the plastocyanin. So now PC will reduce and cytochrome will what oxidize. And when the electron will go cytochrome to PC, okay, so then there will be in this step there will be formation of one ATP here mentioned. When the electron will go cytochrome complex to plastocyanin, so that here one ATP will form. And this ATP is going to form in the presence of the light. So that's why I call photophosphorylation. Okay. Actually, now you all see. I told photosystem is nothing group of photosynthetic pigments. You can see here all the photosynthetic pigments are here. Plus electron carrier protein. You can see that all these pheophytin, PQ, cytochrome, PC. Up to here, photosystem 2 is there. Up to here, photosystem 2 is there. Okay. Now, electron will go from PC to P700. This one is a PS1. And now electron will go from PS1 to primary electron acceptor. And now from there, it will go to where? Ferridoxin. FD for, ferridoxin. FD for what? Ferridoxin. Okay. And now electron will go out from the ferridoxin and it will be accepted by NADP. Finally, electron will be accepted by NADP. And NADP in the presence of enzyme NADP reductase, it will react with the proton and will make the NADPH. Will make the what? NADPH. Okay, will make the what? NADPH. So here, whatever electron ejected from the PS2, this one is a PS2. Whatever electron ejected by the chlorophyll A of reaction center of PS2, it will travel, it will go, SA will go, and finally will be accepted by whom? NADP. Finally will be accepted by what? NADP. Okay. So here, who is the last electron acceptor? NADP, right?
Yes, sir.
And that electron is not coming back to PS2. That electron is not coming back to PS2. Okay. So that's why this pathway is called non-cyclic pathway. That's why this pathway is called what? Non-cyclic pathway. And in this non-cyclic pathway, what form? One ATP form and one NADPH form. Yes or no?
Yes, sir.
And this is called non-cyclic pathway. And when the electron is traveling, so a zigzag-like structure is going to form. A zigzag-like what? Structure is going to form. That is called Z scheme. That's called what? Z scheme. And which scientists call this Z scheme? Okay, Hill and Bendall. Who call Hill and Bendall? Okay, Hill and Bendall. Okay. So what is the Z scheme? Actually, whenever electron travel, in the non-cyclic pathway, a zigzag-like structure will form. That's called what? Z scheme. Who called the Z scheme? Hill and Bendall. Okay. I shall see here. You can see here what form? ATP form and what? NADPH form. Okay. So tell me, in the non-cyclic pathway, what products will form? ATP and NADPH, right?
Yes, sir.
Very good. These are the true products. These are the true products of the non-cyclic, pathway. Okay. These are the true products of what? Non-cyclic pathway. Understood or not?
Yes, sir.
Actually, next one, tell me, from here to up to there, non-cyclic pathway. How many photosystem involved here?
X square plus X minus
this one is the PS2. Okay. And this one is the, PS1. Understood or not?
Yes,
So
sir.
first, which photosystem involved? PS2 or PS1?
PS2.
PS2. Last at the end, who involved?
PS1.
PS1. Okay. Why this pathway is called, non-cyclic pathway?
Electron is not transferred back to PS2.
Electron is not coming back to, PS2. That's why called what? Non-cyclic pathway. Yes or no?
Yes, sir.
Yeah, that's all. So what is the products of the non-cyclic pathway? ATP plus what is that? NADPH plus NADPH. Okay. That's all. So this is called non-cyclic photophosphorylation. Okay. Next topic is there cyclic photophosphorylation. Next one is there what cyclic photophosphorylation. Okay, like you all see here this diagram. This one is the example of the cyclic photophosphorylation. You see here in the cyclic photophosphorylation there is an involvement of only P. Here is written P700. What is the meaning of that? PS1 or PS2?
PS1.
This one is what PS1. In the cyclic photophosphorylation, there is the involvement of only one photosystem. Okay, वो भी कौन है? PS1. Same thing will happen here. Sunlight will come. Photoexcitation of chlorophyll A will happen in the reaction center of PS1. Ejection of electron will happen. Electron will go to where? Ferridoxin. They will go ferridoxin to PQ, plastoquinone. Then one ATP formation will happen here. Now electron will go PQ to cytochrome complex. Cytochrome complex to PC, which is called plastocyanin. Again, one ATP formation will happen here. Now electron will come from PC to back to P700. So here electron ejected from the chlorophyll A of the the reaction center of photosystem 1. After traveling through the several electron carrier, again same electron came back to PS1. Okay, so that's why this pathway is called what? Cyclic pathway. That's why this pathway is called what? Cyclic pathway. Understood or not?
Yes, sir.
And in this cyclic pathway, there is a formation of ATP. Formation of ATP called phosphorylation. And this phosphorylation happen in the presence of sunlight. So photophosphorylation. Further, this phosphorylation happen by the cyclic pathway. That's why we call what? Cyclic photophosphorylation. Okay, cyclic photophosphorylation. Okay, so now you are knowing very well about this is all about the light reaction. And last step of the light reaction already here will happen. Reduction of NADP, reduction of NADP into NADPH. Actually, why I am calling reduction of NADP into NADPH? Can anyone tell me please?
Addition of hydrogen.
Very good. Here addition of hydrogen is happening with the whom? NADP. So wherever addition of hydrogen happen, we say reduction of that happen. Here reduction of NADP into NADPH happen in the presence of one enzyme, NADP reductase enzyme. NADP reductase enzyme. Okay, so that's all. This is all about the light reaction. All about the word light reaction. What is the first step of the light reaction?
Photoexcitation.
Photoexcitation is chemical excitation.
Okay, in that chlorophyll A of the reaction center excited, what ejected?
Electron.
So what is the second step?
Photolysis of water.
Photolysis of water.
In this, what happened?
Breakdown of water molecule in the presence of sunlight.
Light, very good. So who was further? Who was stimulating the splitting of water here?
Chlorine.
OIC. Magnesium.
Full form of the OEC. Oxygen
Oxygen, proton, electron.
evolving complex. Tell me who was stimulating this OEC? Two inorganic
Chlorine
elements.
and manganese.
Very good. Whatever